Hi and welcome back to the devlog for Project Orthros. My goal for the next few devlogs is to get some basic functionalities working. In this one I'll start on unit movement and basic pathfinding. To get started I need to get the mouse position in relation to the movement grid working. In 2D I would just get the mouse position on the screen, maybe calculate the camera offset and call it a day. In 3D this does not work due to perspective. This is where raycasts come in. Raycast is basically an invisible line in space, which usually then collides with something in the world. I'm already using this for selecting and deselecting the spaceship. There are some plugins in Bevy for this, like Bevy Mod Raycast, for example. I share the link in the GitHub page down below. The problem with this is that I will probably need some other physics capabilities in the future as well, like collisions or maybe even gravity. So I decided to go with Rapier 3D. This is a full physics engine written in Rust. There are versions for 2D and 3D physics, as well as specific Bevy bindings. Using this it was relatively easy to implement raycasting, as I just have some examples on the website. To test this I first just made the ship jump around the screen. One mistake I made at first though was to use the same raycasting function as I did for the spaceship selection and just gave the ground plane with the optical grid collider. But since the spaceship is offset in the Z direction, the position is slightly offset from the actual cursor position as well. You can see how this made the ship jump to slightly wrong positions on the map. I was able to fix this by adding an invisible plane as a movement grid, which just has a sensor collider. This also helps if I ever want the ship to go behind a starbase, for example, which is really big, by casting the ray behind it and not onto the starbase itself. After I got this working, I just wanted to test rotation so that I have the equations handy. For this I just set the final rotation to the angle between the x-axis and the direction to the target, to make it seem as if the ship had moved around its axis and flown off to the target. Now that the targeting is working, this term will certainly not be confusing once I start targeting enemies or something like that, I want to get some navigation working. In a previous prototype in Godot I just laid a spline through the starting position and the target position with respect to the current rotation and the target rotation. This approach does look cool in a vacuum, but disregards any other objects like space stations, asteroids or other units which might block the way. One of the classical solutions to this is the A-star algorithm, which allows relatively quick calculation of the optimal route to a target. As a first solution I think this is great, but I think I will improve over time on this. To simplify visualization of the algorithm, I first created a simple 2D representation of my game. While nice, I think this took far too much of my time, but at least it allowed me to refactor the solution while porting it to 3D. So for this, let's first get a 2D grid for movement on the screen. Next we add the ship. Now the ship needs a target to fly to, and some simplex noise as obstacles. I won't go into detail on A-star. Other people have nicely explained the algorithm already. One nice video from Sebastian Lague, I hope I pronounced his name correctly, explains the algorithm well. I will link to his video in the description. While the actual algorithm is relatively simple, implementing it taught me much about data handling in Rust. The usual A-star algorithm is not perfect for realistic movement. It has two major problems. Firstly, it allows moving between neighboring objects if the diagonal between them is free. This is because it visits every neighbor of a node and does not care about any neighboring neighbors. Secondly, it does not care about the orientation of an object. Objects will turn 180 degrees even if it might be more realistic to do this rotation in incremental steps. The first problem is solved easily by always checking the state of the neighboring tiles if a candidate is diagonal and rejecting it if its neighbors are also blocked. The second is a bit more difficult to tackle. At first I thought about just punishing sharp turns. And at first glance, this solves the problem, as sharp turns are usually avoided. The problem arises if the ship later has to pass through a small bottleneck. In this case, it will already have the shortest way into the area, but it might be beneficial to recalculate most of the previous path as well, to have a better approach vector. This can only really be done by adding another additional dimension. Instead of 2D solving, we now have a map in 3D, with the 2 spatial dimensions and the rotation as the 3rd dimension. The idea for this came from a paper called Toward More Realistic Pathfinding by Marco Pinter from 2001. I will have that also linked in the description. The paper outlines some other things such as interpolation between waypoints as well, which for the moment at least I don't consider in my implementation. Now that it's working in 2D, I need to port this to the actual 3D game. All in all, this is not too difficult, but it gives me much to learn about handling data in Rust. I refactored the storage of the cells and information about the cells multiple times until I came upon my current solution. One of my first solutions was to have a 3D vector with the XY coordinates and the heading as an enum translated into an integer as the indices. I adapted this and made the inner part of the 3D vector actually a hash map containing the heading as a key and the A star node as the value. This A star node contains information such as the shortest known distance to the current node and the heuristical distance to the target. To avoid mixing and storing data in multiple different locations, the list of open nodes which are to be analyzed is implemented as a hash set containing just a struct called node coords, which stores the position and heading of a node. This means it acts just as an index into the A star node map. Encoding the path to each visited node happens in a hash map again containing just the node coordinates. The key in this hash map represents the target node and the value is the previous node on the known shortest path to it. This way, once we've reached the target, we can resolve the entire path by just resolving each previous node until we reach the start. With the basic system ported and working, I want to put some final touches on it. I want the ship to actually rotate with a movement in the algorithm. Doing this showed me that I misunderstood the coordinate system. It seems every tool uses a different configuration. Funny enough, up to this point, I was able to circumvent this by working only relative to within the coordinate system. Now I had to calculate the absolute rotation in space, which led to some funny results. After fixing this, it works well most of the time. I think all in all this has been a good first step for unit movement. I still have some kinks to iron out. For example, the spaceship sometimes rotates in the wrong direction, doesn't finish in the correct direction if the path is too short, stuff like that. Furthermore, to make the movement more natural, I will have to implement some sort of interpolation when there are no obstacles in the way. Another problem I've observed is execution time. Even for one ship and short distances, the time to calculate the path is at least noticeable. This means I will have to implement some optimizations, either in form of grid subdivision for the movement grid, or even completely different algorithms. For the time being, though, I will leave it as is to get some maybe more interesting parts of the game working. Next I will look at some UI, spawning of units, and adding more units to the game, like for example some space stations. Thanks for watching my devlog. I've left some links to the resources I used in the description below. The GitHub project is there as well for anyone wanting to have a look at it. Otherwise, if you have any further questions, feel free to comment below, and until next time, bye!